Welcome to Statistics Lessons. I want today to talk about how to calculate an expected value of a win in some sort of a betting or gambling situation. In this case, we're going to look at a lottery. You do have some homework questions like this. In this case, we're going to look at a lottery where this says it's the Ohio Pick 4 lottery. So in this lottery, you pick, I'm sorry about that, I'm still learning some technology here. You pick 4 numbers. So you pick 4 numbers and you can pick the same number over and the digits go from 0 to 9. So you can pick 0, 0, 0, 0 if you'd like. Or you can pick numbers all the way through 9, 9, 9, 9. The first question is how many different selections are possible. You got to be careful here because the temptation is to say, oh, in 4 digits, I can count to 9,999. The answer is actually one more than that because that skips the ones... You think of the ones with a leading 0, but you skip the one that's all 0. So there's actually one more than that. So there are 1, 1, 2, 3, 4, 10,000 different selections. So if there's 4 digits, it's a 1 followed by 4 zeros is how many selections to account for the fact that you could pick 0, 0, 0, 0, which we don't often think of. So there are 10,000 possibilities, and you're going to choose one of them. So the probability of winning is 1 divided by 10, 1, 2, 3. And if you do that in your calculator, you get this 1e to the minus 4. What that means is take the number 1, and there's an assumed decimal here, and move it 4 places to the left. The 1 is 1 place. I add a 0 for the second place, a 0 for the third place, and a 0 for the fourth place. So I get 0.0001. 3 zeros and a 1. Remember, when we count decimals, this is tenths, hundredths, thousandths, 10,000ths. This is 1 10,000th. So you got to keep that in mind when you're doing these problems. You have to, your calculator might give you something that looks like that. So what that means is you have 3 zeros then a 1. If you have a minus 4, it's 3 zeros then a 1. If we're minus 5, it'd be 4 zeros then a 1. But that's why you have it start with a decimal place there, and you move it 4 to the left because of the negative. So the answer to this, the probability of winning, is 0.0001. If you win, what's your net profit? Everybody goes, I won $5,000. Well, not quite. In part C, if you win, you won $5,000, but you spent $1 for the opportunity to win that. So you net $4,999. It's not how much you make, but it's how much you keep, right? Then in part D, it says find the expected value. The expected value is the probability of winning times the amount you win minus the amount you spend. So the probability of winning in this case is 0.0001. The amount you win is 5,000. The amount you spent is 1. So when I multiply 5,000 times 0.0001, just give me a second here. This should be easier than I'm making it. There we go. I get 0.5. So this is 0.5 minus 1. I get negative 0.5. Well, we're talking about dollars and cents, so that's really negative 0.50, 50 cents. If you're talking about dollars and cents, you put that 0 in for the extra. So you're likely to lose 50 cents. Okay, so that's the expected value, is negative 0.50. If you just get it one digit, make it a second one there. Keep an eye on MyMathLab to see whether or not it wants answer to the, usually says answer to the 100th because we're talking about money. So that's the expected value for a $1 bet. For part E, if you bet $1 on the pass line in a casino, dice, game, or craps, I don't even know what that means, and you might not either. But what they're telling you is the expected value is negative 1.4 cents. Which bet is better in sense of producing a higher expected value? So the question here is this negative 1.4 bigger than? Is that better than the negative 0.5 from a perspective of how much you could win? And here they just did negative 1.4. This is negative 1.4 cents. This is 50 cents. And these are both losses. Is it better to lose 1.4 cents or lose 50 cents? well, this one's better. These are better odds. So in that case, you might spend your dollar on the craps game instead because you have a chance of losing less, which means you have a chance of winning more in a sense. But keep in mind that anytime somebody's asking you to gamble, they already know that the expected value of your bet is negative or they wouldn't be in business. All right, so that's an expected value problem. You might find that convenient for when you do your homework.